Let us try to solve the exercise number 1 in the part A of C programming lab. In this program, we are supposed to find the roots of a quadratic equation using if-else ladder. Now, this same question is there for the BSc students also, and for them, it is the fourth question. Here, they are supposed to find the roots of the quadratic equation. However, they are supposed to use the switch statement rather than if-else ladder. So I will be working out both of them in the same video. First, I'm going to demonstrate to you using the if-else ladder, and in the other one, I'm going to just modify it, and then I'm going to show you how it can be, the same thing can be done using the switch statement. So before we venture into the finding the roots of the quadratic equation, let us now first of all find what is the meaning of saying roots of the quadratic equation. Now in your previous classes, that is when you were there in your high school or maybe in the primary, you have studied about the straight lines. So you might have drawn the straight line during your primary or high school classes by giving different values to this. Now, this straight line, you know very well, is represented by an equation y is equal to mx plus c. So this is the equation that we are using. Now, this is also called as the linear equation. Now, the linear because the x term over here, you know very well, if you write x to the power 1, this is same as equal to x itself. So there is no difference between writing x to the power 1 and x. X to the power 1 is x itself. So we don't specify x to the power 1 here, even though it is there, but we don't specify that because it is considered as x itself. However, we can, in this equation, that the m that you have seen over here is actually called as the slope of the equation, and it is nothing but the coefficient of x. So I can rewrite this equation as y is equal to bx plus c. Now instead of, so what is the difference over here is, instead of m, I'm taking b. Now this is any coefficient I can take. You know m is equal to dy by dx and so on so forth. B is also equal to dy by dx. So it is just an equation. So just to give you an analogy. Suppose if you say y is equal to 2x plus 5. So what is the value of m here? So m is nothing but 2. So whether you say m is equal to 2 or whether you say b is equal to 2, it doesn't going to make any difference. So you are just putting a variable here and saying that it is m or it is b. Both of them are the linear equation where b is the slope or coefficient of the x term. Now let's look at a very different term over here. Now what we have here is a very different equation wherein we have ax square plus bx plus c. Now you know very well this is same as writing, instead of b, if you are not very familiar with b, you just write mx plus c, which is nothing but the linear equation. That is the equation for the line that you've studied long ago. You have studied this one. Y is equal to mx plus c, which is nothing but the linear equation that you are familiar with. Okay. Now the question that generally arises to us is what is this term then? What is the let's find out. What is this x square generally represents? Okay. Now you have studied about hyperbola, parabola, and ellipse and so on. All of them have a x square term. So you notice that if you studied about hyperbola, the squared terms are coming there. So whenever you find out the square term, generally you think of this as a curve. So if there is no, if you have this bx plus c or mx plus c, whatever you call it as, this is a linear equation. So that means it is a straight line equation. It's going to go in straight line, either this way, down, or anything. It's just a straight line. But what about this x squared term? X squared is a curvature. So you get the curvature. Whenever you think of the squared term, it is the curvature that is coming into it. So this is actually a equation that represents a curve, not a straight line. So this will represent a straight line, but if together, if you take it, it's going to represent a curve-like structure. So any curve that you can think of, hyperbola, parabola, whatever that comes into your mind, that is the curve that is coming into your mind. So an example for this one is you may write that this is equal to x square plus 3x minus 2. So if you write like this, so you have an x square term, a coefficient of it is 1 into x square. Okay, then the coefficient of b, that is the coefficient of x, that is b, is 3, and the constant term is minus 2. So you get that. Now here we are representing the curvature, and we want to find something with respect to this curvature. The few things you must consider here is that the term a, that is the coefficient of x square, cannot be 0. So what do I mean by saying that is, suppose if you write like this, 0 x square, so 0 x square, suppose if you write like this, 0 x square, okay, plus 5x plus 10, if you write like this. Now this is not a quadratic equation, or it is not a x squared equation. The reason for this is x squared term here is 0 into anything is 0. That means this term is 0. If this term is 0, what you are left with is 5x plus 10. This is same as writing, instead of 5 I write mx, m into x, and instead of 10 I am going to write c. So this is mx plus c, and you know very well mx plus c is nothing but it's a straight line. It is not a curvature. So the minute this term, that is ax, if the a becomes 0, this x square term vanishes. The x square term vanishes, then it is no longer a curve. It just becomes a straight line, and you cannot call this one as the quadratic equation. So what is a quadratic equation? So quadratic equation is the one that has a squared term. So quad means square. So that is the idea. So whenever you have this quad term, remember, in order to get this quad term, the coefficient of a, that is the coefficient of x square, that is a, cannot be 0. That's very important. So whenever you give an input to your program, you cannot set the value of a equal to 0. If you set a equal to 0, then it is not a quadratic equation. It is just becomes a linear equation. Now we know that a linear equation we are representing as mx plus c, and I've already told you x to the power 1 is called as a linear. Now here I have the x squared. So this is also called as second degree, because x square is there. It is called as a second degree equation because the power of x is 2. That is why you say second degree. Suppose if you had something like something like ax cube is there, then here it is called as a third degree, or it is also called as cubic equation. Okay, so here we are not interested in the cubic equation, but we are only restricting ourselves to the x square equation. So this is a plus bx plus c, which is also called as second degree equation, or it is generally called as the quadratic equation. Now, what is the meaning of saying finding the roots of a quadratic equation? What do we mean by saying finding the roots of a quadratic equation? I told you that whenever you have this x squared term, it represents the 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 curve. That is what it represents. It represents the curve. Now we know when we talked about the straight line, whenever we talked about this straight line, one thing that was interesting for us is where does this straight line will touch the x-axis. So where is it going to touch the x-axis, which is the point where this straight line was touching the x-axis. And you know very well, the point where it touches the y-axis is that c, constant term c. So if you don't get it, you are writing this as y is equal to mx plus c. This is what you are writing. So this c represents the intercept with the y-axis. That is what we are not interested in. We are interested in when this line touches the x-axis. What is the value of y here? So y is 0 here. So y value is 0 here. Okay. Then we have y is equal to 1, y is equal to 2, y is equal to 3, and so on. Now below this we have y is equal to minus 1, y is equal to minus 2, and so on. So when if you say that this line touches the y-axis, what does that mean? It means to say that where does the y value become 0? If it at this point y value is 0. So I want to know when this y value becomes y equal to mx plus c. If you're saying that, when does this term, the entire term will become 0? At one particular point, whichever equation you take it, it's going to become the 0. It is going to come to 0. So now let's come back to the our equation over here. Now we have this curve here, that is a curvature here. Now again we are interested in when does this particular curve touches the x-axis, or in other words, when this y is equal to ax square plus bx plus c, when this equation is going to become 0, when that term will become 0. You know very well, if you have the curve here, you draw a curve here, it's going to touch the x-axis at 2 points. If it is a line that you are drawing, suppose if you were drawing a line will touch the x-axis at only 1 point. Now, because it is a curve, it's going to touch the x-axis at 2 points. So you will realize that it's going to touch the x-axis at 2 point. So in other words, whenever we say we want to find the roots, what we are interested in is when this particular term, or whatever equation that you are representing, that is like ax square plus 3x minus 2, when for which value of x this term will actually become 0. So that is what we are interested in. Okay, so let's look at the 3 cases that we are having here. Now this one is very obvious one. So if you have a curve, the curve will touch the y-axis at 2 points. That is obvious one. So when you look at the curve will touch the x-axis at 1 point. That means that equation y is equal to ax square plus bx plus c equal to 0 will actually become 0 at 2 points. But there are other 2 cases where this particular thing can happen. When this can happen? So suppose if you look at this one, this curve will touch the x-axis at only 1 point. So this is the only 1 point where it's going to touch the x-axis. So in this case, y will become 0 for only one value of x. Whereas in this case, y will become 0 for 2 values of x. This is one x, this is the other x. There are 2 places where the y is going to become 0. So when you are coming down here, the y value becomes 0, then the y value becomes negative, 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 again it becomes 0, and then again it's going to become positive. So again look at this one, this is minus, this is 1, y is equal to 1, this is y equal to 2, y equal to 3, and so on and so forth. So from 3 to 1, 0, y value will become 0 here, and then again it will go, let's say this is minus 1, it will again go minus 1, minus 2, again minus 1, 0, again 1, 2, 3, 4. So there are 2 values of x for which y is going to become 0, whereas in this case the y will become 0 only at 1 point. Now let's look at this particular curve. This particular curve will not touch the x-axis. So it will not become 0 in the real space. Then when it is going to become 0, it can become 0 in the imaginary space. So we say that in the real space, it may not become a 0. It may not become 0, but in the imaginary space, it may become 0. This is what we say. So there are three possible cases. Case one is when we have two distinct value or two real distinct value. These are real values where the y will become 0. Second case is there is only one value, one root, in other words, where the y is going to become 0. And the third one is in real it is not possible, but imaginarily you will say that it's going to touch the x-axis. In imaginary, if you draw imaginary line, it will touch the curve. This is what we are going to. Now the question is, how do you find the roots of a quadratic equation? So given the value of ax square plus bx plus c, which is the value of x for which the entire equation is going to become 0? We know that the formula for finding the root of a quadratic equation is minus b plus or minus b squared minus 4ac by 2a. So this is the equation that is given to you. So you take this b, you put it here, and b square is the coefficient of x. Then you have a and c, coefficient of x square, and the constant term, that is minus 4ac divided by 2a. This is what you are representing. Okay. Now in this case, if you just look at this particular equation, now the one that is going to decide the fate of the curve or the three cases are this b squared minus 4ac. Now you know very well, whenever you try to find the square root of a number, square root of a negative number is not defined. You may say that square root of 16 is 4. But what about the square root of minus 16? You know that it is not defined. So two things will come. So square root of 16 is, you know very well, it's a real number 4. You will say that. What about the square root of minus? It is not minus 4. Okay, don't say that it is minus 4, because minus 4 into minus 4, what is this is going to become? This is going to become 16 plus 16, not minus 16. You cannot get this minus here. So this one is imaginary one. So this minus 16 is something that is you cannot imagine. Square root of minus value you cannot imagine. So this is going to be an imaginary case. This is going to be a real case wherein you get the square root of a number. So this particular term will say whether you are going to get the real values or you are going to get these particular imaginary values. So that is what it's going to decide. So this is the term that we are using to find the value of x. So given the value of a, b and c, if you want to find what is the value of x for which this equation is going to become 0, then you have to use this term minus b plus or minus square root of b square minus 4ac by 2a. This term that we are using is the one that is going to decide on the fate of the three possibilities. What are the three possibilities? One of the possibility is the curve will touch the x-axis, and that is the y value will become 0 at two distinct points. When it is happening, when this b squared minus 4ac is a positive number. For example, if it is square root of square root of 16, then you get two distinct value. Suppose if this b squared minus 4ac is negative, then you are, for example, minus root of minus 16, which is not defined, you get imaginary. So this is real, this is imaginary. What if this b squared minus 4ac, the term itself is 0? In that case, what you are going to get? If this term is 0, what you get is minus b by 2a. So you see minus b by 2a. Let's come back to this case. What if this is 16? If this value is 16, what is the answer? You get two answer, minus b plus 16. Assume that this, square root of 16 is 4, very well. So this term, I'm just talking about this term, b squared minus 4ac. If this b squared minus 4ac is 16, then you have square root of 16, which is nothing but 4. So what you get here is minus b, it is minus b plus 4 divided by 2a. This is one possibilities. Okay. What is the other possibility? Again minus b, then plus or minus is there, minus this 4 divided by 2a. This is the other possibilities. So you get two distinct value. So that is what I told you. The curve will touch the x-axis at two places. One is here, the other one is this term. So two places the curve will touch. What if this term itself is 0? If this term becomes 0, that means square root of 0, which is 0 itself. So plus 0 minus 0 will not make any difference. Adding or subtracting 0 from any number will not make any difference. So what you are left with is minus b by 2a. So you get only one value for x, for which x, the y value is going to become 0. So in other words, this is the case wherein your curve will touch the x-axis at only one point. So based on the value of this b squared minus 4ac, so the b squared minus 4ac could be, there are three possibilities are there. One is it is a positive number like root of 16. So other one is it is a 0. So that is the next one. The next one is it could be minus something like minus 14, minus 17, or anything, any value for that. So if it is positive, the curve will touch the x-axis at two places. Okay, y at two places, minus b plus or minus is there. So if it is 4 plus 4 minus 4, two values we are going to get. If it is 0, this term itself will vanish. So this term will vanish. So you get only one value, minus b by 2a. If it is negative, definitely minus of something, square root of minus is not defined. So it is going to be an imaginary term. So now the question is, how do you find the square root of minus 16? What is the square root of minus 16? You know very well. Minus 16, you can represent it as square root of minus 1 into 16. So square root of minus 1 into 16. So what is square root of minus 1 into 16? Square root of minus 1 into 16 is square root of 1 into square root of 16. So what is square root of 16? Square root of 16 is 4. Okay, so it is square root of minus 1 into, remember there is no square root of negative number is not defined. So we are calling this square root of minus 1 as imaginary term. So this is I is nothing but root of minus 1. So we are going to write it as I4. Generally we don't write it as I4. Generally we represent it as 4I. Why this 4I? You know very well. Multiply 4 into minus 1 or 1 into minus 1 into 4. You know very well. This is A into B is same as B into A. So you put it I before 4 or you put I after 4. It's not going to make a difference. You're just multiplying it. So this I, by the way, this I is nothing but square root of minus 1, which is the imaginary term. Now, so we know very well, based on the value of b squared minus 4ac, if it is 0, we get two places where the curve will touch the x-axis. If it is 0, b squared minus 4ac is 0, it's going to touch at one point. And if it is not touching at all, that is if this value b squared minus 4ac is negative, it will not touch the x-axis at all. Okay, now let's give you a simple example wherein I have the equation b squared minus 4ac is equal to 0. So I have taken it as a 1x squared plus 4x plus 1. This is the equation. So what is x here? What is the value of a here? A is 1. Remember, 1 into x square is x square itself. So a is 1, b is 4, c is 1. So let's try to calculate this equation. Let me put this entire thing in the minus b plus or minus b squared minus 4ac by 2a. So the b is 4 here. So minus b minus 4 plus or minus b squared. So this b squared, b is 4 here, b squared minus 4 AC. 4a is 1, c is 1. 4ac divided by 2a. So divided by 2 into a. So what is this is going to be? So this is going to be, 4 square is 16. 4 into 1 into 1. So 4 into 1 is 4. 4 into 1 is 4. So this is 4 square. 4 square is 16. 16 minus 4. So this term is nothing but 16. 4 square is 16. So this term is 16. Okay. Minus 4 into 1 is 4. 4 into 1 is 4. So this is 4 itself. 16 minus 4 is going to be 12. So this is going to be minus b, that is minus 4, plus or minus square root of 12 by 2. So what are the possible values that you can get it? So this is minus 4 plus square root of 12 by 2. That is one answer. The other answer is, sorry, this should have been, this should have been 4 here. Okay, this should have been 4. Okay. So 4 plus square root of 12 and 4 minus square root of 12. So minus 4 plus square root of 12 by 2 minus 4 minus square root of 12 by 2. So you are going to get the answer as one is 0.27, other one is 0.36. So this is how you are going to get the answer. Now because you are getting two real values, so you can say that the curve will touch the x-axis at the two points. Okay. Now I have done the calculation for the other values. So if I take the values of a equal to 4, a equal to 1, b equal to 4, and c equal to 1, you know that this is b squared minus 4ac is 12, which is positive. Okay, so it is positive, greater than 0. So I get the value of root is equal to c. Now suppose if you take the value of a is equal to 1, b is equal to 2, and c is equal to 1. So this is b squared. So what is b squared? The b is 2 here. So 2 square minus 4ac. Now you know very well a is 1 and c is 1. 4 into 1 into 1 is same. So 2 square, you know very well, b squared is 2 square is 4. 4 minus 4 is 0. So you get the value of the discriminant as 0. Okay, suppose if you put that in the equation b squared, this equation, where is the equation gone? Suppose if you put this in this equation, that is what is this, minus b plus or minus b squared minus 4ac divided by 2a, you're going to get the answer as minus 1 and minus 1. Suppose if I take a is equal to 1, b is equal to 2, and c is equal to 3. So let's try to calculate this b squared minus 4ac. So what is b squared? B 2 square. So 2 square minus 4 into a is 1 here, 1 into 3. Okay. B squared you know very 2 square you know very well. 2 square is 4. 4 into 3 is 12. 4 into 1 is 1. 4 into 1 is 4, and 4 into 3 is, if you multiply it 1, it will not make any difference. So 4 into 3 is 12. So I'm going to just take this one. 4 into 12. So 4 minus 12. So 4 minus 12 is minus 8. So what you are going to get here is minus 8. If you substitute this one in the equation, this values of b squared 4ac in this equation, you are going to get the value of plus 4 1.4i. Remember, I is the square root of minus 1. This is minus 1 minus 1.4i. I means square root of minus 1. Remember, so I told you I is imaginary term and I is equal to, what is this? I is equal to square root of -1. This is what we are representing here. So this is going to be an imaginary term. Now you know very well how the equation has to be, or how this particular thing has to be solved. So now straight away, let's go to the code block. I'm going to go to the file, and I'm going to click on new, and I'm going to go to the file here, and you can select this C++ source, click go, and the first two you can just skip. Okay, so because we are writing a C program, we will just use this, and your teacher would have told you where to save the file. Just click on this ellipses, three buttons over here, this three button ellipses. So three button ellipses, and just give a what to say, a file name. Let me give it as a quadratic. You can give anything, quadratic equation. I just say quadratic equation. It's up to you. Okay, save it. So I have it in my particular location, that is quadratic equation. You can give anything, quad, your name, anything. Just click on finish, and you have your the C program ready with me. I'm going to just zoom in for you. So you know very well, for any C program, you include stdio.h. Okay. And because I have to find the square root, I'm going to include one more term, and that is the math.h. That is because I have to find the square root. Okay. Then I'm going to go with the void main. So remember, if you are using int main, then you have to return something. I'm using void so that I don't have to write a return statement. You know very well what are the things that are required in this particular equation. To solve this particular equation, we need the values of a, b, c, and we have to find the discriminant d. So I'm going to get the values of the coefficient a, where is this gone, a, b, and c, and the discriminant d. And you know very well there are two possibilities are there. One possibility is when you have, let me go over here, when you have two distinct value, R1 and R2, you will get it, and the other one is imaginary. So I'm going to use the R1 for the first root, R2 for the second one. So which is this case? This is the case wherein I have this one, I'm calling it as root 1, R1. The other one I'm going to call it as root 2. Okay, then you know very well, then you get this one for here, R1 is equal to R2 because it is the same value. You don't get any different value. R1 is equal to R2 because it's going to touch the x-axis at only one point. Here it's not going to touch the x-axis, but I am saying that for an imaginary plane, it's going to touch the values at two different places. And you know very well how to write a complex number. C is equal to, or in your previous classes you might have studied, z is equal to x plus iy. You might have studied like this. So this y is, x is called as the real term, the y is called as the imaginary term. You might have studied a complex number, or c is equal to x plus iy. Just remember that. So we are going to represent it in the form of a complex number. So that is what we are going to do it. So I want, whenever you are thinking about a complex number, you are going to use what is this? You are going to use, suppose say you are writing z is equal to, or c is equal to, complex number c is equal to real term plus the imaginary term. So this part is going to be the real term. So this is going to be the real term, and this part is going to be the imaginary term. So I will call this as ing. So I'm going to take two more variable. One is called as real, and the other one is the imaginary term. So I will say two more variable. One is real, the other one is imaginary. Done. We need to read the value of the value of the coefficient. So I'm going to use a printf statement, and I'm going to say printf enter the values of coefficient A, B, and C, not this one. And I'm going to put one space here. Remember, you put one extra space and then put the double quotes. Don't just put the double quotes immediately. Put one space and then put the double quotes. I'll tell you what is the purpose behind it. Okay. Then I'm going to use the scanf function. In the scanf function, I have to read three numbers A, B, C, which are floating point number. Remember, both A, B, C, these things are floating point numbers. So I need to read three floating point numbers. So this is the first floating number. I'm going to put the space, then the second floating number, put a space, the third floating number. Three floating numbers. These floating number has to be stored in the location represented by A, in the location pointed by B, and in the location pointed by C. So how do you say that? So the first floating point number that I'm going to read has to be stored in the address given by A. Second one has to be stored in the address given by B, and the third one has to be stored in the address given by C. So that is it. Then what is the next thing? So how do we say that these three curves are different? How do you distinguish between them? You know very well, it is the discriminant. B squared minus 4ac will decide whether the curve will touch at 2 point, whether the curve will touch at 1 point, or the curve will not touch the x-axis. So we have to find the discriminant. That is why we say it as a discriminant. Discriminant means to say that it discriminates, or it decides which type of curve are you going to get, the one that crosses the x-axis, or the one just touches the x-axis, or the one will not touch the x-axis. That is why we call it as a discriminant. So let's try to find the discriminant. So I'm going to call this as D. D is equal to B square. B is square is nothing but B into B is B squared minus 4 into A into into C. So this is what I'm going to say. So B squared minus 4AC, let me slightly zoom in. So B squared minus 4AC. So I get the discriminant. So what are the possible values you can have? The discriminant can be either greater than 0, equal to 0, or less than 0. If it is greater than 0, you get real roots. If it is 0, you get single root. If it is minus 0, you're going to get the imaginary roots. So let's try to go with all the possibilities. So I'm going to say if the discriminant that you got is greater than 0. So what is the meaning of saying if the discriminant is greater than 0? If this value b squared minus 4ac, if it is greater than 0, you get two distinct value for your roots. So you get your real roots, and you are going to get the two values. So which are the two values? And I've told you that the two values that you can think of is this one, you can call it as R1. The first one is R1. The second one is R2. So I'm going to take two values, R1 and R2. So let's take that one. That is the reason I took the value R1 and R2. So I'm going to get the two real values. So what is the real values? Real value is this equation. What is this equation? B squared plus minus b plus square root of b squared minus 4ac by 2a. This is one value. Other value is what is the other value? Minus b minus. So you have this plus or minus here. So first one is minus b plus square root of b squared minus 4ac. Other one is minus b minus square root of b squared minus 4ac. So you are going to get two different values for this root. So let me take the first value, that is the b squared plus, that is minus b plus b squared minus 4ac by 2a. That's first value. Minus b plus b squared minus 4ac. That is the first value. Next one, R2 is minus b minus b squared minus 4ac. So I'm going to take this one. So how do I'm going to do this one is I'll put the square bracket. So because I have to follow the BODMAS rule. So remember, you just can't do it without putting the brackets. If you forget to put the brackets, you will not get the answer. Remember, if you just say without this, if you try to do it, without this, if you try to write it, without the bracket, if you try to do it, then you will not get this answer. What you are going to get is minus b will be left over, then square root of b squared minus 4ac will be the next term plus this term. It is not that whole thing has to be divided by 2a. So that bracket is very much required here. Without the bracket, if you write it, you get a very wrong answer. So I'm going to say square root of, again, I will not calculate b squared minus 4ac. This one I've already calculated here. So this is b squared minus 4ac. I call it as d. So square root of d. Okay. This bracket, why did I put this bracket? The whole thing, that is this whole thing has to be divided by 2a. Remember, okay? So this whole thing has to be divided by, again I will put 2 into a. Why not 2a? Remember, if you just put 2 into a, it will first divide this whole thing. So if you try to do it, what's going to happen? If you don't put bracket, what's going to happen? This whole thing, it will divide by 2, and for the remaining answer, it will multiply it with. This is what you are going to get if you don't put the bracket for 2a. So remember that even for this 2a, you have to put the bracket. Now I'm not going to write this whole thing here. I'm going to select this whole thing, Control C to copy and Control V to paste. Okay. So the next term that, let me put it here also. So the next term that I'm going to get is R2, that is root 2 is first time it is b plus square root of b square minus 2a. Next time it is minus b minus. So only thing I have to do here is I have to change this one as minus. So I got both the roots here. I'm going to use a printf statement, and I'm going to say printf. And what is that? I can say over here is real roots are percentage. I see if you just put f here, what's going to happen is you're going to get an answer with like 0.0007 zeros, so you will get it, which is not looking good. I don't want such a high precised value. I just want 2 decimal places. After dot, I want only 2 decimal places, not the remaining. So how do I say that? So I'm going to, I don't going to say that it is f. I'm going to say point to f. What is the meaning of saying point to f is you may get many answers. So like 3.4567 something, very lengthy answer. So what I'm saying is I want just 2 decimal places answer, only 2 decimal places. Remaining precision answer I don't want. That is the meaning of putting 0.2 here. So it is not 2, it is 0.2. Remember that. Okay. And let me put there are 2 values. This is for R1. The other one is for the R2. So I'm going to say 0.2f. This is for the R2. So first one is for R1. The second one is for the R2. So this value R1 will come here. R2 will come to this value. So this is what I have done. So this is one part. So if the value of R is greater than, where is it gone? If the value of discriminant is greater than 0. What if the discriminant is equal to 0? So let's go ahead and let's do that thing. Else if I'm going to say if d is equal to 0, that is b squared minus 4ac, this one, if it is equal to 0, you know very well, if it is equal to 0, the curve will touch the x-axis only at one point. So you get only one root. So let me try to find that root. Let me say R1 is my root. How do I get it? Remember, if this term b squared minus 4ac, this term is 0, that means d is 0. Square root of this 0 is 0 itself. So you add 0, minus b plus 0, minus b minus 0. It's not going to make any difference. So I will not going to write this whole thing. I know how to use Control C for copying, Control V for pasting. So I'm going to just paste it, and I don't want this term. Remember, this time if you find it too difficult to or if you're finding it difficult with the putting the bracket. You can ignore the bracket because it's only one term. Remember, both the roots are same, so r1 and r2 value will be the same. So r2 is equal to r1. Remember, this is actually not required because you won't get two roots in this case. You will get only one root. But because I said there are two roots here, so r1 r2, so what I'm going to say is r1 r2 values are same. R1 is same as the r2. In other words, I'm saying that what is this one, r2 is same as r1. Okay, so this is the meaning. So this is what I'm going to write it here. R2 is equal to, where is it gone now? Okay, r2 is equal to r1. That means to say that r1 and r2 are the same values. Let me use a printf statement because it is printf. What we can say over here, so these are equal roots, so I'm going to say equal. Remember, you can say only you can put one root, but I'm going to put two roots also. Equal roots are percentage point 2f and percentage point 2f. Okay, then I have r1, then I have r2. So two values. Remember, it's going to print. So in the examination, what if I just put equal root is only one value? It is valid because for the second time there is only one root, because it's going to touch the x-axis only at one point. You won't get the second point here, but we just say that the first point and the second points are same. Okay? It is not actually the case. It will touch the x-axis only at one point. Now for the last one, what if this one is a negative? So let's go with the last option. So I'm not going to say one more else if. I'm going to just say, some people don't like me putting like this, so I put it like here only. Okay, this is see, this everybody has their own style. I like to put the bracket directly here itself after the else itself, but some people don't like that thing. What to do? Okay, everybody has their own choice. See, when you have this case, when let's go to this one. So here, remember, you cannot find the b squared minus 4. You see, it's a negative number, and you know very well square root of a negative number is not defined. So you have to do some trick here in order to get this one. So what is this value? This is any value like 0.67, 0.5 or something. I, what is I? Imaginary term. So what is I? Square root of minus 1. Just recall what I have said. If you have the value square root of minus 16, what did you do? Square root of minus 16 is square root of minus 1 into 16. Okay. Then you said that it is square root of minus 1, square root of minus 1 into square root of 16. Okay, and you know very well square root of 16 is 4, and so square root of minus 1 is called as an imaginary term, that is I. So this is I4, or generally we say it is 4I. Okay, this term is imaginary. It is not existing because minus 1, square root of minus 1 is not defined. That is term. What about this term minus b by 2a? What about this term? This is real term. Minus b by 2a you can always calculate. So this part you can always calculate. This part you can always calculate, but this inside part, this part you cannot calculate. This part becomes imaginary. What about this part? This thing, that is minus b by 2, is the real part. So this is real. This is real. You can calculate it because there is no square root of minus 1. Remember, square root of minus 1 is called as imaginary term. There it is not there in this term, but this term has the square root of minus 1. So what is it's going to become? 4i, but remember by 2a. Okay, how did I write this one? If you are wondering, remember this can be written as minus b by 2a. Okay, minus b by 2a, plus or minus, okay, square root of b squared minus 4ac, b squared minus 4ac, this term as it is, b squared minus 4ac divided by 2a. So what did I do? I split this part with this part with this. In between plus or minus I put. This part is the real part. Okay. This part is the imaginary part. I hope you get that. Why this part is imaginary? Because I told you if this is minus 16, so what you get is 4i. So I is the imaginary term. What is I? Square root of minus 1. So this part is imaginary, this part is real. So we will calculate the real part and we will calculate the imaginary part separately. So let's go ahead and let's do that thing. So I'm going to say real part is, what is real part is minus b by 2a. Okay, 2 into a. This is the real part. What is real part in this equation? What is the real part? Real part is this term minus b, plus or minus is not there, minus b by 2a. This is the, what is this real part? What is imaginary part? Imaginary part is this one, square root of b squared minus 4ac by 2a. Remember, this is a minus value, it is not defined, so careful with that. So I'm going to say imaginary part is, you cannot say square root of b squared minus 4ac, square root of b squared minus 4ac, and you know very well b squared minus 4ac you have already calculated here. B squared minus 4ac is d. Square root of d, suppose if you do this one, square root of d divided by 2 into a, if you do this one. So this is the imaginary part. I told you square root of b squared by 2a. This is the imaginary part. This is what I told you. But you know very well this part is negative. So suppose if you run this one, you will get an error saying that negative value of d is not defined. So I'm going to say minus d. What is going to happen in this case? So what you had here is square root of minus 16, and square root of minus 16 is not defined. So what I'm going to say is square root of minus of, remember this d is minus 16, minus of minus 16. You know very well minus into minus is plus. So this is going to become 16. So I'm going to get square root of 4. Then I have to put one extra I here. I'm going to put it manually, that I here. So that is the reason I put minus here, because if you directly put the value of d is going to be minus 16, and you will get an error saying that when you run the program, runtime error you are going to get saying that square root of a negative number is not defined. So how do you make it as positive? Just multiply it with minus 1. That is what I'm doing it, minus 1 into that whatever d value is there. So this is minus of minus of d. So d is, if d is value is minus 16 or minus 4, anything, so it is minus of minus, and minus of minus is positive. So you are going to get the positive answer, and you won't get any error message. Okay. So let me write the printf statement. I'm going to say printf, and what is that? I'm going to say imaginary, this is an imaginary, okay, roots, okay, are, okay, the first one I'm going to represent. So how do you represent the first one? Imaginary roots are percentage point to f plus, you know what is this point to f? Percentage point to f, but very important, I'm going to put this I. So you, what is this fi you have written, sir? If you are saying that, remember how did I wrote that thing? Square root of minus 16. How did I wrote it? This is 4. This is 4, and I am manually writing it here. So this I that I have written here is to say that square root of minus 16 is 4 into minus 1. So minus 1 I am representing it as a I here. So that I extra I that I am writing it is here. So this part, first part is the real part, second part is the imaginary part. So this is going to be some value here, and this value will be some value here, but extra thing here what you get is I. This is first part. There will be two roots. Remember there are two things here. There are two things, minus b plus this one, minus b minus this one. So this is how I am written is, this is minus b plus something, minus b plus something. So this is plus that I'm talking about. Next time I have to write the same thing, minus something. So I'm going to write one more printf here, printf, and I'm going to put one extra space here. Look at that, I'm putting one extra space, otherwise they will touch each other and come. Okay, so and then one space. Look at here, one space, and after that one space, then I'm going to write a point to f minus percentage point to f. So the first part is the real part, the second part is the imaginary part. Okay, so what is this? This is minus b, this is minus b plus b squared minus 4ac. This is the first part, plus b squared minus 4ac. Next time what you are saying, minus b minus b squared by minus 4ac by 2a. This is minus, so the second part is minus. Again I have to put this here as I, one extra I, because you know very well, whenever you write a complex number you say c is equal to x plus yi. What is this I here? I, that what we are talking about, I, this I and this I is the imaginary term. So that's just to make it as imaginary term. Now suppose if you are using turbo C, which I'm not using it, it's outdated compiler, you will have to write conio, that is console input output .h, and some people are writing a clear screen. All these things are not required if you are using the code block, because it's using the latest compiler, and a clear screen is actually taken out from the console input output.h. So C, if you look at the C programming languages, C has improved, the different version of C has come. The latest version of C does not support that clear screen that you are familiar with it. CLR, SCR that you are writing, that function is not defined in the latest version. So if you are using this code block, this will work. If you are using your turbo C, then you may have to put some get ch or something of that type. I'm not going to do that. Let me put save everything and let me run it and just see whether if there is an error. So if there is no error, it's going to quickly go ahead and let's try to give the answer. So I'm going to give this answer which I've tried tested here. That is, first one is 141. So I'm going to get to three values. Remember, how did I write this three values? If you look at here, I accept three values, everything separated by space. This separated by space, this separated by space. So I'm going to write this value, that is a equal to 1, b equal to 4, c equal to 1. So I'm going to say 1, 4, 1, press enter. What is the answer I'm going to get? Minus 2.7 and minus 3.7. This is real roots. So real roots. Why? Because d square, that is d, that is nothing but b square minus 4ac is positive. Let me run it here. So one of the complaints that I have received by the student is, you run this program, you keep it here, and then again come and then say, sir, there is no option for running the program, sir. It is not coming here. Whenever you have this problem, just look at the taskbar here. If you find this kind of icon in the taskbar, that means you are still running this program. So you have to come out of this program. How do you come out of this program? Press any key, this will go, or you press this X mark. It's one and the same. So I pressed any key and it's gone. Let me run it. Remember, only then this thing is going to come. Let me run it again. And this time I'm going to put these values, which are these three values. I'm going to put is this value 1, 2, 1. So see, I put the space here. That is one thing I wanted to tell you. So when I said that you put a space here, after C you put a space, the reason is otherwise it will touch the C. This blinking cursor will touch the C. It will touch the C and you will get the value. So that's the reason I told you put the space. Okay, so let's go ahead with this one. A is 1 and B is 2 and C is 1. So in this case, D value must be 0 and you must get the repeated roots. So you get the roots are same, equal roots, that is minus 1 and minus 1. So you get this value. Let me press any key and continue. And let me go ahead with the last option. Let me go with the last option. And what is the last option? Let me run it first and let's see what I'm going to get. So I'm going to run this program. Where is it gone? Okay. So when I run this program, where is it gone? Okay, just give me a second. Okay. And let me give this value. So remember, this is going to be this is going to be minus. Actually, this is not plus. This is going to be minus 4. Okay, this is going to be b squared minus 4. This is going to be minus 4. I'm not going to. I have written the Excel formula there. That's going to be minus 4 there. So this is p squared minus 4 AC will be negative value. So let me say, what is this? So 1 to 0. Did I put that? I think that is not the value. 1 to 1. I think 1 to 2 was my value. Let me put that. This is 1 to 2. Let me make it as 1 to 2. Okay, so minus 4. You get it. So now it is correct. 1 to 2 is the value. So if you type 1 to 2, get I think I lost the value here. Okay, some concatenation error it came. Don't worry, but you're going to get that same answer there. Some, I think my formula went wrong with somewhere. You get the, forget that Excel. Okay. You get the value as a minus plus something minus and this. So this part is the real part because there is a I here. This is the imaginary part. This is the real part. This is going to be the imaginary part. Now coming to the BSc students. So what is that they are going to do? So for the BSc student, so this is for BCA students. So for the BSc student, what they have said is this thing has to be pulled out. And they said for BSc, so BCA student, your time is over. So you can close the video. For BCA student, this part is over. So this is for BCA student. For BSc student, let me go to this BSc student. For BSc student, they said demonstrate using switch statement. Actually, I'm not in favor of using switch statement here because it's not the construct that should have been used here, but they said that you have to use it, so I'm going to do it. So what to do? The if statement is the right statement there, but if you are using switch, same story. Now what are the two possibilities is D is either greater than 0. So remember when you have the comparison operator, what are the possible output for a comparison operator? Either it is true or it is false. True means 1, false means 0. So only two possibilities are there. So I'm going to go and say if it is true, that means if it is 1, so case is 1, okay, then whatever you have written here is all valid. So let me put one space extra here because it will go out of the screen otherwise. And you know very well at the end you have to put a break. Okay. What if the case is, let me say, case is 0. Where is it? Case is 0. So if this is positive, if what is the meaning of case 1? If this statement D is greater than 0, if this is true, then this part is correct. What if it is not true? Then you have two possibilities. Either D is 0 or D is less than 0. So three possibilities are there. Either D is greater than 0 or it is equal to 0 or less than. If it is greater than 0, you get the answer. If it is not greater than 0, then you have again two choices. What are the two choices? Either it is equal to 0 or if it is less than 0. So what I got here is if it is greater than 0, you know very well it is the real roots. So if it is greater than 0, so if this is true, you get two real roots. If it is not greater than 0, I am again going to check whether it is equal to 0. So here, if this is the case, so what I'm going to do here is I'm going to write one more switch statement and I'm going to say whether D is actually equal to 0. So one more case statement, switch statement. So if it is, let me put it here. So if it is equal to 0, okay, then you know very well you get a repeated root. I will not put so much of space here, otherwise I will go out of this. So if it is equal to 0, same story, you get the same answer. Now you have two possibilities. So when you compare D is either greater than 0, or it less than 0, or it is equal to 0. So here what we have done is we have checked whether D is greater than 0. If it is greater than 0, the roots are real and distinct. If it is equal to 0, then you have only single root. Otherwise, what is left over is this part. It is not greater nor equal, then it must be less than. So this time again, I'm not going to write one more switch statement. So if it is greater than 0, then roots are real and distinct. If it is not, then you check whether it is not greater than 0. Then two possibilities are there. Either it is equal to 0 or less than 0. If it is less equal to 0, this is it. What is left over now is, I'm going to put just a break statement here. Break. What is the next case you have? So where is the case? Sorry, what is this? This is a case. So this case is 1. So case is 1. Where is that? What is that? It is typing. So if it is equal to 0, that means it is true. You're going to do this one. Otherwise, you're going to write case 0. Case 0 is this one. Okay. So this is like your BCA program. It is not different from the BCA program. Only thing is they have complicated you by giving you a case structure, and you know very well if you are using case structure, you will have to use let me put some people don't like me putting this one. I don't like that. My way of putting it is, after this I put the equal. So this is my way of doing it. So everybody has their own way of writing the code. Okay. I put the open bracket immediately. Now do I have the way of formatting it? Where is this formatting it? Okay, I formatted it. So let me start with it. If it is greater than 0, so you get 2 distinct. If it is not greater than, then you check for whether it is equal to 0. If it is equal to 0, you get only 1. Otherwise, it is imaginary. So you are going to say this is the one. Okay, let me save it and let me run it. Sorry, this should have been the colon. That for switch statement you use the colon. So okay, that's it. Now do you get a different answer? The answer is no. I'm going to run it for 1 for 1. So 1 for 1. I won't give the explanation this time because you know very well. You get the, it is real. You get the answer. Now I'm going to rerun again for the other one. And I'm going to do it with the 1 to 1. So 1 to 1. Okay, you get -1 and -1. So done. I'm going to rerun again one more time. 1, 2, 2. You must get the plus 1 plus imaginary, 1 plus 1 imaginary. So you get that. Don't worry about this one. This is because I put 0 here. You should get, I think this is because when I concatenate, something is going wrong. I use a concatenate here. I think that concatenator has some problem with that. Okay. Excel function, something it has done. Okay, whatever it is. So that's it. In this exercise, we will meet again in the other class. Thank you for your interest. I'm going to stop the video now.